Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. I'd like to quickly introduce myself. My name is Indah Rizki Anugrah and I am a lecturer at ICMScE Nurjati Cirebon. I'd like to take this opportunity to present my presentation, and the title is Scientific Content Analysis of Batik Cirebon and its Potential for High School STEM Approach Project-Based Instruction. Well, first, let me talk about the background of this study. Education is now facing many challenges as consequences to the fourth industrial revolution, which is happening all over the world. In this technology disruption era, education has become an inevitable part for other sectors' success, especially in the economy. So the education system must be able to create human resources who have these competences. Some of the competences we usually heard as 21st century skills are ability to solving complex problems, critical thinking, and creativity. STEM education is becoming a trend over the world as a solution to these challenges. As we see, the need for human resources with a STEM background is increasing over time, along with the increasing number of jobs in the sector of economic science and technology. The example is in America, Finland, Australia, Malaysia, Vietnam, and Philippines. Research on STEM in Indonesia itself has been initiated since 2013, which focused on integrating STEM education and teaching and learning in primary and secondary schools. However, there are more difficulties to implement STEM education in senior high school compared to lower schools. The structure of senior high school curriculum is not thematic as in elementary schools. Also, its subject is taught by different teacher, different from elementary school, where students remain with a single teacher for a large portion of time. Well, changing the current curriculum structure is not the best option to be taken. The most possible way to integrate STEM without restructuring curriculum is the embedded STEM approach to the specific subject matter. In this approach, the domain of knowledge is acquired through problem-solving techniques in social, cultural, functional context, and also emphasized through expert-like activities on real-world situations. The study took Batik Cirebon as a context. Based on the data in 2013, there are 530 industries, including 4,408 workers in the batik industry. This shows that both in terms of economic and socio-cultural aspect, batik industry have a large role for the people of Cirebon. But unfortunately, until now, batik industry in Cirebon pays just a little attention to the environmental sustainability. Um, Several studies have shown that water around batik industry area is in polluted condition. So this context, in my opinion, is ideal to be analyzed because batik is a local wisdom industry that is potential to be developed as a theme for students' project in STEM approach senior high school chemistry instruction. The study is a preliminary research of the development of STEM approach chemistry instruction for high school. The focus of the study is to analyze scientific content structure of the batik making process. Okay, now we talked about the method. The study is a descriptive qualitative research exploration of scientific content aspect of batik Cirebon context conducted using model of educational reconstruction, or we can call MAP. This design is commonly used to reconstruct relatively new knowledge or innovative contexts in science that are not yet available in the school curriculum. Merit rests on two aspects: scientific content or scientific discipline spec, um, and, and, and its educational aspect, including students' perspective on a chosen subject and the design of its learning environment. The study focused on the first aspect, the scientific content, which is exploring the structure of the scientific content of batik Cirebon making process, including materials, tools, and waste produced from each processes. And this process is carried out through literature study of batik Cirebon and direct observation assisted by open interviews of reputable batik craftsmen. Um, let me move to the result and discussion. The first is about the process of making batik Cirebon. Well, there are three main components needed: fabrics, waxes, and dyes. And the process of making batik consists of the first one is anglengreng, which is the batik pattern tracing on fabrics that has been cut. And then isen, application of wax design to the fabric using a traditional tool called chanting. And then the third process is nembok, the process of blocking part of fabric that will not be colored using wax to dry. And then ngobat, coloring process by dipping fabrics in certain dye solution. And the last one, the finishing process consists of lorot. Lorot is washing fabrics in hot water and drying it under the sun. And the second, this is the linking scheme between the scientific content of batik with the concept of high school chemistry. As we see in this picture, the scientific content of batik is related to many high school chemistry concepts. When we talked about the main component, first the fabrics, we can see that this context is related to polymers. Also, when we talked about waxes, it talked about another macromolecule, the lipids, and about the dyes. There are two concepts related. First, aromatic derivatives, because the most widely used dyes in batik Cirebon industry, naphthol and indigosol, are aromatic derivatives compounds. Uh, and then the second one is about electromagnetic radiation, um, which is describing how color is produced. Dyeing fabric is through acid base and redox reaction. Um, Depends on the type of dyes used. If used naphtha, acid-base reaction occurred, while redox reaction occurred if used indigosol. And then about the process of making batik, uh, there are three chemistry concepts related to it. The first one is polarity, and then stoichiometry and chemical bonding. So, from from the result of this study, we can conclude that scientific perspective of batik is related to many high school chemistry concepts, especially aromatic derivatives and polymers, electromagnetic radiation, chemical bonds, acid-base, redox, and stoichiometry. Referring to the most dominant related concepts and the sequences of high school chemistry concepts, the context of batik can be applied in chapter of organic chemistry. And the last one, the result of this research can be used for further research on the development of teaching materials and project-based learning using the embedded STEM approaches in batik Cirebon as a context. And that brings us to the end. I'd like to thank you for your time and attention. I would now be interested to hear from you with your thoughts and questions. Thank you.